Okay, now we're going to look at some polynomial functions and a different way to maybe evaluate polynomial functions for a given input. Also take a look at how to factor, dealing with factors of polynomials. Okay. So the first two questions are fairly straightforward. I'm just going to show you a slightly different method to do it. So you're given a couple polynomial functions. You just want to evaluate each of these at -2. Well, clearly one way we could do it is to substitute in the -2 as our input. Just get that all calculated, and I think we do that, we wind up with 0. There's another method though, one that will help us as we move forward, and that's synthetic division, remember. So synthetic division, we're going to think of it as dividing 5x cubed minus 6x squared minus 28x plus 8 divided by x plus 2. Remember, if you have x plus 2, then the 0 would be the -2. Okay. So when we do the synthetic division, remember, you take the x minus c, so that you have a -2, and then the coefficients, making sure not to skip any. So we have 5 as our x cubed, -6 as our coefficient of x squared, -28, and 8. Remember, synthetic, the first one comes down, then you multiply these to get -10, that goes in this spot. Always add coming down. Do this multiplication, -2, -16 multiplies to be 32. Again, always add coming down. And -2 times 4 is -8. And then 0, and you should just put that there. Okay, so remember what this means is when you divided it out, you get 5x squared, you decrease the power by 1, minus 16x plus 4. Okay. Now again, how does this help us find p of -2? Well, remember, if you wanted to check a division, you would take your answer, 5x squared minus 16x plus 4, times the divisor, x plus 2, and remember that would equal your original. Okay. And so then we can see, if we want to plug in -2 into this, which is what we did to begin with, we could, because they're equivalent, plug in -2 here. Okay. When you plug in -2, this piece becomes 0, which makes the whole thing 0. Okay. So p of -2 is 0. Okay. Let's do the same thing here for number 2. So again, we're going to use synthetic on -2. Now again, we have to be careful not to skip coefficients. So the coefficient here is -1. There's no x cubed, so it's 0x cubed, 3x squared, minus 4x, and a -5. Okay. And so first one just comes down, multiply, that goes in the next column. Always add coming down, multiply, add coming down, multiply, -2 times -1, add, multiply, and then add. Okay, now notice there's a remainder here of -1. So again, I would claim that p of -2 is -1. Okay, and again, just to sort of see why that's true, we're going to do the same thing we did up here. So when we divided -x to the 4th plus 3x squared minus 4x minus 5, we divided it by x plus 2. By the synthetic, we get this. Remember, the power decreases by 1, so that's -x cubed plus 2x squared minus x minus 2, right? Plus that remainder of -1, which we usually write like this. The remainder over the divisor. Okay. But again, when we check, you sort of do the multiplication we did here. So how would we check this? We would say that if we take our answer, -x cubed plus 2x squared minus x minus 2, I'm going to hold off on the remainder for a second, times our original divisor, plus the remainder, remember, which was -1, that should be the original. So again, we wanted to originally plug in -2 into this piece, so instead we could plug -2 in here. Again, when you plug in -2, this whole piece becomes 0, and you're just left with that remainder of -1. Okay, so we'll see as we go forward why synthetic division to check for factors and things like that may help us. All right, so just a few more that we'll run through a little bit more quickly here. So again, is x equal to 2 a 0 of this polynomial function? So remember, you want to know, is p of 2 equal to 0? Okay, that's the question. If 2 is a 0, it means when you plug it in, you get a 0. So we plug it in using synthetic. Again, our coefficients are 1, -4, 9, -10. Multiply, always add coming down. Multiply. We get a remainder of 0. So in fact, yes, p of 2 equals 0. And yes, x equal to 2 is a 0 of p of x. Okay. Similarly here, if you want to know if -2 is a 0, then you plug it in. I'm going to plug it in through synthetic. So we have 3/2, -1, 3/2. Be careful, you also need a 0, right, for the constant term. First one comes down. Multiply, we get -3. Add. Multiply, we get 8. Add, remember this is 16/2, so this would be 19/2. Multiply. Yeah. So our remainder is 0. So p of -2 is -19. Okay. So x equal to -2 is not a 0 of p of x. It didn't output 0, it's outputting -19. Same thing here. Again, just a slightly different way to word this question. Is x plus 2 a factor? Well, again, that would mean that p of x equals x plus 2 times something with no remainder. So when you plug in -2, you would want to get a 0. So again, we plug in -2. Write down our coefficients. We get a remainder of 0. So yes, x plus 2 is a factor of p of x. And then similar here, remember, if you're checking to see if x minus 1 is a factor, that's the same question as saying, is x equal to 1 a 0 of p of x? So we plug in the 1. Remember, we have no x cubed, 0x cubed, 3x squared, -5x, 7. Multiply, add, coming down. Our remainder is 7, so no. X minus 1 is not a factor. You would need remainder 0. All right, so now let's just work with a bigger polynomial. In this case, this is usually our ultimate goal, is to find the zeros or the factors. Okay. So we have a polynomial given to us. I want to show you, this is degree 3, and I'm giving you the 3 zeros. So the first thing you're asked to do is show they are in 0, or in fact 0, so we want to plug them in. I'll just plug in the first one. You can plug in the other 2. So if you plug in -2, it's 2x cubed, 5x squared, -1x, -6. Multiply, add, multiply, add. Okay. Our remainder is 0, so that worked. And you can do it for the other 2. If we have our 3 zeros, we can write 3 linear factors. Now we're going to be a little bit careful here, which you'll see in a second. We'll leave a little bit of space here. But if -2 is a 0, right, x plus 2 is a factor. If -3/2 is a 0, x plus 3/2 is a factor. And if 1 is a 0, x minus 1 is a factor. Okay, the only thing we're missing here is that leading coefficient. So right now you could see if you started multiplying, you would get x times x times x, which is x cubed. You need it to be 2x cubed. So you just need the 2 here. Okay. And again, if we want to solve p of x equal to 0, right, we already know. That's what makes the function 0, which we know to be -2, -3/2, and 1. Okay. Nice quick problem when the zeros are given to you. Okay, now this one, we have again a degree 3, but I'm only... Okay, so we're obviously going to need to find the other two. Okay, but we have one of them, so we already know that p of x, if 1 is a 0, x minus 1 is a factor. We need this other piece, but again, that's just our synthetic division. We want to divide out x minus 1. So I have 2x cubed, negative 3x squared, negative 5x, positive 6. Now again, this should be 0 because I tell you it's x equal to 1 is a 0. Make sure. Okay, that worked out. Okay, but again, now I also have the other piece, right? This is the remaining factor. So you decrease the power by 1, so it's a 2x squared minus x minus 6. Okay. And then we just need to try to factor it some more. But again, now this down to a quadratic. Hopefully we can factor. If not, we'll use the quadratic formula on that. Okay. But again, let's give this a try. X squared, 2x squared, sorry, would be 2x and x. We need our middle term to be negative 1x. So I think, let's see. I think a 3 and a 2 should work, right? If I make this negative and this positive. Okay, so that's 2x squared. Our outer and inner terms are negative 4x, positive 3x, which is negative 1x, and then negative 6. Okay, so these are the factors. Okay, now it's not asked, but we could also, if we have the factors, we have the zeros. 1, this is 0 at negative 3 halves, and this is 0 at 2. All right, and then just a similar one for the bottom. Again, you're given a hint. It's a degree 3, so we're looking for 3 of them, but I already have one. Okay, so p of x, and again, I'm going to write it in factored form first. Is x plus 5, and I'll do a division to find the other one, the other factor. Again, if I'm told negative 5 is a 0, the remainder should be 0. And it is. Okay. And more importantly, I have this remaining factor. All right, so now we have our two factors. If we could factor it some more, like we did above, we could get our other zeros. All right, so again, 2x squared is 2x and x. The difficulty is here we need it to be minus 1. We can only have a plus 1 minus 1. And neither one will give us a middle term of negative 2x. So this one doesn't factor, all right? So that's okay, we'll just do the quadratic formula on this piece. So when we're going to get our zeros here, I can't factor it anymore, but I have this first one, and then I'll just do the quadratic formula on the 2x squared minus 2x minus 1. Okay. So remember, that's the opposite of b, which is positive 2, plus or minus square root. B squared is 4. Minus 4, your a is 2, your c is negative 1, all over 2a. So this is 2 plus or minus the square root of 4 plus 8, which is 12 over 4. Just do a little cleaning up here. Or you could take a 4 as a perfect square, so that would be 2 root 3. And then if you factor out a 2, you'd be left with 1 plus or minus root 3. All over 2. Okay. And those would be our two other zeros. So 1 plus root 3 over 2, 1 minus root 3 over 2.